back to Maths with Mrs. J. We've been talking about the unit circle, and we've been learning about the fact that from now on, instead of thinking of sine as being opposite over hypotenuse, cosine adjacent over hypotenuse, tan as opposite over adjacent, which is fine for right-angled triangles, we can expand our thought process about that, and we think about sine as being the y value of a particular point. Now, of course, we have our x value is our cosine, and our tan is our y value divided by our x value, or in fact sine divided by cosine. All right, so this is our position in our first quadrant where we have theta here. You can see I've put a theta next to the horizontal axis in each quadrant. I call this, I don't know if other teachers do or not, but I sort of dub this a horizontal reference. For a pretty obvious reason, the thetas are all next to the horizontal axis. All right, let's have a bit of a think about this point over here. This point in the second quadrant, how would we talk about the position of that point in radians? Well, we've gone all the way around to pi and we've come back by theta, haven't we? So we could refer to that angle as pi minus theta. I want to actually get some values here, get some insight into what's happening for sine, cos, and tan of pi minus theta. All right, let's have a bit of a think about this. Sine is your y value, so it's b. That is exactly the same as sine of theta. So sine of pi minus theta is sine of theta. Cos is your x value. Now we've moved to the left there, so it's negative a, which is negative our cos theta. Tan is always going to be your y divided by your x. So we get negative what tan of theta was. So that's interesting, isn't it? We get the same magnitudes. The only difference is that some of these ratios are negative in that quadrant number 2. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. All right, let's think about our third quadrant. How would we talk about this position on the outside of our circle? Well, we've gone around by pi, and then we've gone around by theta more. So we could think of this as sine of pi plus theta, cos of pi plus theta, tan of pi plus theta. The angle is pi, and then you've gone around by theta more. All right, well, sine here is negative b, which is the same as sine of theta, but it's negative. Cos of pi plus theta is negative a, which is the same as cos of theta, but it's negative. Now, tan is always going to be your y divided by your x. When you do negative b divided by negative a, you get positive b divided by a. So it's in fact exactly the same as tan of theta. So the tangent of this point here is exactly the same as the tangent of that point there. Interesting. All right, and our final quadrant, we could either refer to this as a negative theta, which I will do for now, or you could refer to it as 2 pi minus theta. Now, the reason why it's negative theta is that, of course, you have gone back the other way, haven't you? So normally we go around anti-clockwise. If you go clockwise, that counts as a negative angle. All right, sine here is negative b, which is the same as this, but it's negative, so negative sine theta. So sine of negative theta is negative sine theta. Cos of negative theta, all right, well, the cosine value is the x value here. It's actually exactly the same as cos of theta. That blows a lot of people's minds. A lot of people think cos of negative theta, you have to have a negative in there. No, it's actually exactly the same as cos of theta because they have the same x values. Tan is your y divided by your x, so that's the same as this, but it's going to be negative. All right, now let's try to summarise and work out what on earth we just learnt there. What do we know? Well, whenever we do what I refer to as a horizontal reference, which means when you have your theta next to the x-axis, so that's going to be like a pi minus theta or a pi plus theta or a negative theta, you actually have the same trig ratio. So sine will be sine, cos will stay as a cos, right? Tan will always stay as a tan. The only difference is that the sign, S-I-G-N sign, might change. So in your first quadrant, they're all positive, aren't they? In your second quadrant, the only one that's positive is sine. So they're all positive there. Sine is positive there. The only one that's positive here is tan. And the only one that's positive here is cos. So we get our sine from all stations to central. And there you have it. We're going to do some examples in our next video and it will become clear how easy it is to work with this. What I definitely do not want you to do is to go and take these 12 rules and learn them off by heart. A little bit of understanding can save a mountain of rote learning. And if you have that little bit of understanding and know what questions to ask yourself, this is actually really easy.